So they give you the equation here. So we're basically just going to plug in an x, plug in a y, and see what happens here. So 5 equals a to the first. So a is 5. So f of x equals 5 to the x. Same thing over here. We're going to plug in our x, plug in our y, see what happens. This might be more difficult than that one. 9 equals a to the negative 2. That is more difficult. So this would be 1 over a squared equals 9. So 9a squared equals 1. So a squared equals 1/9. So a equals 1/3. I know it's positive, not negative, because the way the graph looks. And so it would be f of x equals 1/3. Try to put that in parentheses to the x. At least one point should be labeled. Be nice to label more than one. Okay, so let's start with the parent graph. Y equals 0. So if you get the point there in the parent graph right there, basic behavior looks something like that. So this negative 2 does two things. So like if you think of that starting point as 0, 1, we're going to multiply the y values by negative 2. So that new y value would be negative 2. That'll become the y-intercept actually. So that's the y-intercept. On the behavior on the left, it still approaches the asymptote, kind of hits that point, moves down pretty fast. If you want to get another point, maybe plug in 1. So that, I mean, obviously 1 point there is 0, negative 2. So if you plug in 1, that would be 1 comma negative 2 times 3 is negative 6. So if you go all the way down, 1, 2, 3, 4, 5, 6. So I guess it looks about 1 comma negative 6 would be an extra point that you could plug in and get up on this point there. And this one, again, start with the parent graph, y equals 0. So it's got a lot of movement to this one, right? So normally the parent graph goes through 0, 1, looks like that. So it's going to move to the right 2 and down 4. So I'm going to take the asymptote and move it down 4 first. So there's an asymptote at y equals negative 4. The point that was at 0, 1, that was the point at 0, 1, and now it's going to move 2 to the right and down 1, 2, 3, 4. So now that's going to be at 2 comma negative 3, I believe. And the graph, let's see. So it's still on the left, approaches the asymptote, so it's going to look something like this. And on the right, it's going to go up pretty quick. Let's just plug in another point. Let's plug in 3 and see what happens. So 3 comma, let's see. There would be 3 minus 2 power, which is first power. 3 minus 4 is negative 1. So I'm going to plot that point. That's why I waited to do this. So now I've got a nice point there that I can go through and get my bonus point. I like the expression. So if you know your properties, that's just equal to 3. There's a bunch of ways to do that. 3 to the what power is 27 is what you're thinking if you change the form of that. So 3 to the third. 8 to the what power is 1. So that's 8 to the 0 power. These are just properties. This is a little tougher. If you're having trouble, you can just change the form of it. So we could write 3 to the x equals 1/9, or 3 to the x equals 1 over 3 squared. That's, of course, a negative 2 power because it's in the denominator, so x is negative 2. If you see the property, natural log of e of e, just like log 3 of 3 is always going to be 1. E to the what power is e. Because the bases match here, the answer is just 2. That's one of our properties. I hope those are easy for you. Okay, here's our formula. So you have to know which formula to use when, right? So how much money would you invest to get 50,000 interest paid at rate? Compounded continuously, so we've got to use the continuously compounded interest formula. So A of 6, the amount after 6 years will be principal, which is put in 50,000, times E to the power of RT, so 0.04 times t, which is 6. And then you just get out your calculator, type that in. This would be 50 times e to the power of 0.04 times 6. So that's equal to 62.5. And if I mouse up, let's see if I can see more digits. Actually 0.46, right? So better to put 0.46 there. 63,000. That's okay. That's all right. Let's see this one. Your grandmother gave you a savings bond when you were born worth $100. Interest is compounded semi-annually. How much money would the bond be worth if you lived to be 100 years old at 5% interest? Okay. So let's try this one. So we've got our formula is the A of t, so amount after 100 years is going to equal the principal, which was only $100, times 1 plus the rate, which is 0.05, divided by how often it's compounded, which is 2, to the 2 times t power, and t is 100. Wow, it's a lot of years to compound here. Okay, so this is going to be 100 times 1 plus 0.05 divided by 2 to the power of 2 times 100. 13,000. I'm a little disappointed it's not more, but we only started with $100, so can't. Well, let's just actually let me check that. 0.39. Oh, 0.39 is amazing. It keeps rounding it on me. It's better to see the number there. Okay, find the domain of the function. Use your calculator. Don't use your calculator. It's going to be harder to do on your calculator. So just set that greater than 0. So 2x plus 1 greater than 0. So 2x greater than -1, divided by 2, you get x greater than -1/2. That's your domain. Find the domain of functions. This one's kind of interesting. Let's find the domain of this piece. So this piece, x has to be greater than 0. This piece, x minus 2, must be greater than 0. X greater than 2. So I would say these both have to be true. Like in order for it to be the function, I mean, we've got to, you can't have part of it, oh, this won't work, but this will work, kind of thing. So if you think about those both together, where are those both true? Where x is greater than 2 would be the answer there. Because one, it would work for one of them, but not the other. If that makes sense. Sketch a graph, label a point. Show graph asymptote. So this one just has a little bit of transformations here. So, oh, why did I do that? Sometimes you get into exponential form thinking, and then you go, oh, wait, this is a log graph. So this is going to be an asymptote that starts at x equals 0. The point and the behavior starts like this. This is our parent graph. Okay, so what happens here? So this is a reflection over the x-axis. So it's going to start up here and go down like that. That's our graph. If you want to show off, let's plug in another point. So I know it's going to be at 1, 0 there. But 2, let's plug in 2. So this would be, oh, that'd be easy. Log base 2 of 2 is 1. So it'd be -1 because there's a negative in front. So 2, comma, -1 right about there. That looks about accurate. You have your tick marks, and you get a bonus point for that. Okay, this one, again, start with your parent graph. X equals 0 is where it starts. I don't think it's going to stay there. So it starts there, something like that, roughly. Okay, so we're going to move it to the left 1 and down 2. So to the left 1 really does change the asymptote. So the new asymptote will be x equals -1. The point started at 0 or 1, 0. Now it's going to go left 1 and down 2. So now that point is at 0, comma, -2. And the behavior of the graph starts low and kind of goes up. I'm just going to plug in 1 and see what happens here. So 1, comma, this would be log base 2 of 2 is 1. 1 minus 2 is -1. So right, it's going to go actually through that point right there. So it's pretty good. And that gets you your bonus point. So just kind of push these together, it looks like, using our properties. So this would be log base 4 of, because I don't know log base 4 of 8, it's kind of a tough one, but this is 64. Oh, that's not bad. 4 to the 3rd power is that, so that's just 3. Are we supposed to solve it or no? To simplify, yeah, that's where we're supposed to solve it. That's good. This one, put that up there as an exponent. Log base 3 of 3 is 1, so 1 plus log base 3 of that to the -1/2 power. Or sorry, it's actually 9 to the -1/2 power. 1/2 is like square root of 9, and negative is like it's in the denominator. So, I mean, you can think of this different ways, though. You could also rewrite it. I mean, there's so many different ways to think of this. So log base 3 of, you could write this as 3 squared to the power of, that's a 2 there, 3 squared to the power of -1/2. So that's really just 2 times -1/2, which is -1. So that's 3 to the -1, which is 1/3. So, or just keep it that way. So log base 3 of 3 to the -1. Whoops, that's to the -1 inside of there. And so log base 3 of 3 goes away, just -1. So it's 1 plus -1, which is 0 after all that. Wow, that's kind of crazy. You could have pushed this together as well. So maybe I should have done that. So if you did that, this would be log base 3 of, let's just kind of think that through. So that'd be inside of there, it'd be 3 times 9 to the -1/2. 9, again, that's square root of 9, which is 3, and it's the denominator. So it ends up being 3 over 3, which is 1, and the answer is 0. Just double check it and think it through that way. It works that way as well. Expand this. So this time we are supposed to expand. I would take care of the division first. So natural log of x minus 1 squared minus natural log of x. Still have an exponent there, so let's take care of that. So that would be 2 times natural log of x minus 1 minus natural log of x. That's good. Write this as a single logarithm. Move those first. Any kind of coefficients that kind of move up. So this would be natural log of 2 to the 3rd plus natural log of 2 minus natural log of x minus 5 to the power of 3, I guess, there. So let's push these together first. So that would be natural log of 2 cubed times 2 minus natural log of x minus 5 to the 3rd. Push those together, so it'd be natural log of, big fraction, 2 cubed times 2 over x minus 5 to the 3rd. That's one logarithm. Pretty happy with that. Change of base, just rewrite it. So this is equal to log of 15, if I change it to base 10, over log of 3. So we might have to use your calculator for this one. So let's change the form. That's typically how we solve. So log base 2 of 34 equals the exponent, which is 3x, divide by 3, divide by 3. Just type that in your calculator at that point. So it'd be a fraction, log, so that'd be log base 2 of 34 over 3, and control enter. That's x is equal to 1, or approximately equal to 1.6958, or exactly equal to that if you didn't want the 4 decimal places, so that'd be good. Put in log form, natural log 16 equals 3 minus 5x. Subtract 3. Natural log of 16 minus 3 equals negative 5x. Divide by negative 5. Type that in your calculator. So natural log of 16 minus 3 outside the parentheses over 5. I probably Control Enter. So that would be x is equal to, or approximately equal to, 0.0455. So this one, so just change the form. 3 to the third equals 2 minus x. So 27 minus 2 is 25. Equals negative x. So x equals negative 25. Well, that one just worked out. I didn't need a calculator. This one, well, that must be equal to that because our log of something is log of something. So x squared minus x equals 20. Set it equals 0. It's a quadratic. Minus x minus 20 equals 0. I'm guessing 4 and 5 here. Let's see. So x and x, 4 and 5. Bigger numbers, negative. X equals negative 4. X equals 5. Check your answers. Ooh, I didn't check my answer here. Ooh, did this work? Oh, it does work. 2 minus negative 25 is 27. That's an answer. Whew. Always a good idea to check your answer here. So negative 4, that would be 16 minus 4. That does work. That's a positive number. 25 minus 5, that works. So don't forget to check your answer. Wow, I almost didn't check my answers there. It's easy to forget. And last problem, yeah, use the finance app to solve this. So, oh, I need the calculator again. So you can manage, let's see, if you can manage to save up and invest $1,000 every single year, that's important. This can be a payment, right? Because it's recurring. Your investment makes 9% compounded annually. How long would it take to make $1 million? Okay, so finance solver, always start with percent. That's 9. Present value is 0. We're just making a payment every year. Negative 1,000 because I'm paying it out. Don't make your payment and your future value positive. You get an error message every time. You want $1 million once a year. N is, I think, what we're solving for. How long will it take? This is in years because N is 1. So it'll take approximately 52.3 years. It's just $1,000 a year. Wow, it's not bad, right? It's like a little less than 100 a month. It's very doable. You'd be a millionaire. Have a good day.